Hello, everyone. Thank you for joining in Data Science Salon, and thank you, Data Science Salon, for inviting me. My name is Aida Farhadi. I am Senior Data Scientist at UPS, working on several projects. But this presentation is going to be more related to my thesis, which I have done my PhD on. I have done several internships in the healthcare. That's why I was excited to just talk about it. My first internship was as Children's Healthcare of Atlanta. The second one was at the Mayo Clinic. And I've seen a lot of the challenges in specifically healthcare data and the application of the transfer learning and how that could be useful. And my thesis is about that specifically. So let's go ahead and get it started talking more about the application of transfer learning in real world. When we are talking about transfer learning, as the name suggests, it is basically transferring knowledge from pre-trained model to the new model. So assuming that you have two different models and you are trying to utilize the one of them in order to get the knowledge and facilitate learning on the new task, that would be the concept of transfer learning. And mainly what we mean by transferring is transferring the weights, because weights are the ones that is learned during the training and gets updated at each iteration and helps model to learn basically from the data. If we can, we want to just get a sense about what it specifically means in terms of just the normal situation as a human being. For example, think about if we as a human know statistics and math, that's going to be easier for us to learn machine learning. It's the same, because if model knows something basic ahead of time, it can easily learn the new knowledge. So this way we can just digest the concept of the transfer learning. And as I bring here, the example is that a simple classifier that is trained to identify the backpack in the image can be utilized to identify the other objects in the image, such as sunglasses could be a good example. Comparing traditional machine learning and transfer learning, as I explained, for traditional machine learning, we had different data sets and different tasks associated with those data sets. However, in transfer learning, we are trying to utilize different tasks. So we are basically bridging the gap between two different tasks in order to just utilize them rather than starting the new task from the scratch and, spending a lot of the energy and stuff on that. I would like to also emphasize on deep learning in the middle. As we know, deep learning in the last 5-10 years appeared to be pretty important and really powerful, but still that needs a little bit requirement, including the large data set, computational stuff, and GPU, TPU, cloud computing, in order to make the learning possible. However, transfer learning makes it more possible because we do not need that huge data set. We can just utilize the model that is already pre-trained by big data and customize that on the smaller data that is available for us. And specifically when we are talking about healthcare, since in the healthcare there are a lot of problems gathering all of the data together because of either privacy issue, security, or the integration, which is not always available at the hospitals about the data set, transfer learning could be a big opportunity in order to facilitate this learning on the small data set, which we will talk about that more on later slides. Why we need transfer learning? Because As I said, for the deep learning models, they appeared to be working pretty well, and they learn the representation of the data, but still they need a lot of labeled data set. This is a good scenario when, for example, the ImageNet, which has been trained on 14 million images with more than 1,000 objects, and we have the availability of the labels. However, in terms of the healthcare, for example, we do not have such a big labeled data set, because the only people who can label the data set in the healthcare are surgeons or medical doctors, and they cannot waste their time just, sitting and labeling the healthcare data. So that is a problem. Also, insufficient amount of the data causes the low performance. If we do not have large data set, it's always recommended to work with traditional model rather than deep learning. So that's why we can utilize transfer learning instead. And on the other side, as you know, training the deep learning takes time because of the big data. It takes time, it takes the computational stuff, and also it takes a lot of the time from the data science perspective in order to handle this large data set. That makes it a little bit more important to think about transfer learning specifically, as I said, when there is a problem with deep learning. Other than that, deep learning has been proved itself to be a good way in order to handle the data set and get a good result when there is a huge amount of the data. And also we can think about, transfer learning is not new technique. It is architectural work in order to handle the machine learning techniques and utilize in a better way. And it is transferring knowledge. It is not creating new algorithm or new techniques to do the machine learning. Main benefits of the transfer learning is, of course, it starts from the learned knowledge rather than random initialization of the weights, which is pretty good opportunity in terms of the neural network, because they normally starts from the random initialization of the weights. And then higher learning rate, we do not need the small learning rate because the model is already trained, so it doesn't need a small learning rate. And it's going to improve the accuracy of the training because we are starting from the known point and the higher learning rate. And at the end, we're going to get better accuracy in the lower amount of the time, which is really good benefits of the transfer learning. Specifically nowadays, the time is invest, and we are trying to do the trainings jobs as fast as possible. Talking about different categorization of the transfer learning, we have different categories which can be generalized in terms of the image transfer learning in the images, transfer learning in the text, transfer learning in healthcare text, and so on and so forth. This is just a more general categorization. There are some other categories based on different survey reviews. One of them is instance-based transfer learning, which I have seen in literature review of the healthcare that there are two methods for instance-based transfer learning. One is hard transfer, the other one is soft transfer. In hard transfer, you transfer the instances, not the features, and directly from source to the target model. However, in the soft transfer, which is more popular, is that you reweight the instances that you want to transfer to the target model. And that has been utilized in some of the papers that they were trying to transfer the instances from one facility to another facility, but the data set was related to the similar patients. And the other one is mapping-based transfer learning, which I have seen has been used a lot, specifically for the images. And in that sense, we are trying to map source and the target into the new space such that the difference between features gets smaller. And there are some statistical ways that actually I have used in my thesis in order to reduce this distance between source and the target. That could be, this distance can be measured by different distance metrics, and there are different ways like KL divergence, Shannon divergence, in order to measure the distance between these two and see how compatible these features are in order to make the transfer learning possible. The other one, which is pretty popular and specifically it is used a lot when we are talking about deep learning, is network-based transfer learning, where we utilize pre-trained network and transfer that pre-trained model into the target domain and try to retrain or fine-tune that onto new data set. That could be by either saving the weights and transferring those weights, or just saving the whole architecture and transferring that to the target domain. The last one is adversarial-based transfer learning, which uses the adversarial method in order to find the instances that are more transferable to the target. This actually just appeared after, the GANs started to showing up, so there is not much transfer learning related research going on with the adversarial-based transfer learning, but there is opportunity to more explore this area and do more some use cases in this area. General applications of transfer learning are learning from the simulation, which we can see in self-driving car, robots, games, adapting to new domain, which can appear actually in any domain, and it is more popular application compared to the others. For example, it can be utilized in the healthcare, robots, image recognition, and also from 2018, we are seeing application of transfer learning in NLP. Specifically, BERT and GB2 and transferring between cross languages are appearing more and more, and we are seeing more in the concept of the texts. Talking about learning from simulation, so doing like self-driving car in the real world scenario is most costly, and applying them in the simulation and then transferring the knowledge would be more cost saving. However, we're gonna have the same feature space because we are trying to transfer knowledge from pixel to pixel, but the marginal probability distribution of two environments would be different, because one is getting done in the simulation area and the other one is getting done in the real world. If we can make the objects that we are working on in simulation more similar to the real world, then this gap could be smaller and the transfer learning could work better. The other one is robotic. As we know, learning the robots is a pretty slow process, and also it is expensive. That's why training them in simulation area and then utilizing the knowledge that is already trained from could be more helpful and reduce the time and the cost of training the robots. This is pretty popular application of the transferring knowledge to the new domain, which can appear, as I said, in pretty large and broad environments, such as image recognition. The model that is utilized to identify dogs can be utilized to identify cats. Autonomous driving, the model that is used for driving cars, can be utilized for driving trucks. And for gaming, the logics that are being used for playing chess can be utilized for AlphaGo, and the knowledge from AlphaGo can be utilized to a more developed gaming problem. And also in the healthcare specifically, the model that is trained on the EMG signals can be utilized on EEG signals. And for spam filtering, a model that is trained for categorizing the email can be utilized to identify the spams in the email, because spam also is category. John, just one small explanation about this part is that when we are talking all of these transferring knowledge, it is normally a good assumption to think that the original model, the source model, is more general compared to the target model. You are starting from the original model and transferring the knowledge from original model to a more specific customized model, which is your problem and you are trying to solve. Specifically in the healthcare, there are a lot of challenges which might not be the case in other industries, such as e-commerce. For example, high dimensionality of the data set and the lack of the data. We will have more missing values in the healthcare. Gathering all of the data together is a problem in the healthcare. Labeling is an expensive part in the healthcare. And we have class imbalance problem because patients who have disease normally are a small set compared to patients who do not have disease. Also, feasibility is a problem in the healthcare because if you want to make a diagnosis, it might be painful for patient to do some tests, to do some examination, and that might not be feasible in order to gather all of the data and have a big data set to do machine learning or any types of the other statistical analysis. And as I said, security, even for the big hospitals, is still gathering the data together, integrating them is a problem because they all are dealing with different types of the privacy with the data set that are private for that specific department, and gathering them under one cloud is a little bit impossible. And so in healthcare, we can see the challenges regarding that still human being, we are trying to understand the disease, and there are always effects of the human intervention, and we do not have integrated data. These are the main challenges specifically in terms of the healthcare. This shows the 7 layers of applying transfer learning in the healthcare, and we can start from the inner loop to the outer loop, applying different types of the transfer learning. The other categories are inductive and transductive and unsupervised. Inductive basically is when you are trying to, when the source and target data set could be the same or different, but the tasks are different because you are using induction in order to transfer the knowledge. And the example are multitask learning or self-taught learning. On the other side, transductive transfer learning is when the task is similar, but the data set is different. And then we have the CNN, RNN. As we know, the CNN or deep convolutional neural net is the popular one, which is mainly used for the images, and such that the lower layers try to learn the edges, the corners, and as we add more layers, the upper layer try to learn the abstract representation, more like the texture and the shape of the object. And then we have the classification, imaging modalities. These imaging modalities are used in order to capture the image and try to identify the problem with the body. For example, if it is a lump, if it is a fibrosis, that can be identifiable with the MRI or CT scan rather than surgical identification procedure that needs to be done, and that could be helpful for the patients. So utilizing these images and processing them could be really beneficial for the healthcare and for the patients, and could save a lot of money and time for both of them. And then different applications area, we can see that it can be utilized for the pathology, lungs, heart, breast, brain, and the different systems of the human body, like the immune system, muscular, nervous, and renal. I have a better, yeah, it is on the next slide anyway. So this was just the overview of where the transfer learning can be implemented, and just explanation from bottom to top of the transfer learning to the healthcare. And here you can see some of the transfer learning applications in the healthcare. They are in the skin cancer, breast cancer, prostate cancer, and the data set are images. The source data is AlexNet, ResNet, ImageNet. You can see that they are, and we already know that they are pre-trained models that are open source in Model you can find them, and they are being utilized in order to make classification on the target data set more feasible. And you can see here the target data set are more specifically to specific disease or specific institute, and the type mostly are network-based transfer learning or feature-based transfer learning, and they improve the accuracy of the prediction. As we know, in the specifically healthcare, the sensitivity is important. So that's why I brought also here the sensitivity number of the true positive that has improved after implementing the transfer learning. This is just a small number of the studies that have been done in transfer learning from the overall studies. In last 5 years, more than 7,000 studies has been implemented in transfer learning, and it is going on and on. You can see like 90% of them are on the images, and the rest are either on the video, audio, or text. But that is really broad area in the healthcare. And we can classify that in terms of the diagnosis and application. Even for like the ICD-9 coding, they have used the mesh categorization and facilitate the classification of the ICD-9, or for diabetes, cancers, the images can be utilized in order to identify the cancer in the target data set. And the type of the data also could be the images, text, like the medical record, and medical images, video, or audio. Here is different categorization of the transfer learning. It can be homogeneous or heterogeneous. Homogeneous when the feature space between source and target is the same and the target is the same. For example, both of them are about the heart disease, and also both of them are images. On the other side, heterogeneous is when the feature space is different. One of them is image, the other one is text, or the target is different. One of them is heart disease, the other one is skin cancer. In order to make transfer learning possible, it's always recommended to do the statistical analysis and make them homogeneous, and then start doing transfer learning. Other than that, there is always possibility for negative transfer, which is not really good, because that's going to reduce actually the accuracy rather than improving it. And on the right, you can see different types of the transfer learning in healthcare, which is similar to just the general classification. And then at the end, we have transfer learning in NLP, which started in 2018 with paper that Google published, Attention is All You Need. As we know, in the images, transfer learning was popular because we had enough data, we had enough labeled images. That was not the case with the NLP until in 2018 that transformers came to the play. And on the right side, you can see different branches of the application of transfer learning, which is the same as a general categorization. The popular transformers, as I explained, are BERT and also GPT-2. Also, there is a new version of the BERT. So the problem, as I explained, for the transfer learning was we didn't have labeled data set for NLP models. BERT is trained on unlabeled data set. It is trained on more than 2,500 million words from the Wikipedia and more than 800 million words from the books. So it is really enriched model that could be utilized and make transfer learning possible on target model. And specifically nowadays, using this transformers with the GPU is more possible because we have enough computational work in order to make it possible and get the results. And then here are different techniques of the transfer learning. You can either train the entire architecture, which in that case, they're going to back propagated and the pre-trained weights are going to be updated. Or you can freeze some of the layers that are transferred and leave the others alone. So you can keep the weights of the initial layers frozen while retrain the higher layers in order to make sure that you get customized with the target data. And you can freeze the entire architecture and attach some layers at the top. So that could be the other form of the fine-tuning techniques, which can utilize when we are trying to implement the transfer learning techniques. The best practices for the transfer learning is that when you have a pre-trained model available, try to utilize it rather than spending your time, money on training from the scratch. That is highly recommended, and be aware what is your source model, and if it is similar to target model, there shouldn't be a lot differences between them to make transfer learning possible and useful. Also, the larger data set, you can just handle that with the traditional models. You do not need transfer learning for that. And also make sure when you are using transfer learning, try to freeze the layers, tune the learning rate to make sure you do not overfit. Thank you so much for your time, and that was all about transfer learning.